Hello, my name is Amanda Pennington, and we are going to be going over Module 2. Okay, so today we're going to be talking about relationships and operations on sets and using sets to solving problems. So just to go ahead and get us aware, we're going to talk about relationships and operations on set. So this diagram is going to show you set A is substance of B. Since this is B and A is in B, it becomes a substance of B because it belongs in B, if that makes sense. Okay, and this is going to be called an empty set. An empty set has no elements and is written as a 0. It doesn't have anything in it that belongs in there. It's completely gone. There's no numbers, no amount in there. And this is called unit sets. And this is called AUB. And so what that means is union sets are sets that are of all elements that are in A or B. So we're looking at the equation AUB, and since the Venn diagram shows that all of A is filled up and all of B is filled up, and even A and B portion of the Venn diagram is filled, it means all of it is going to be included in that problem. Next, we're going to be talking about equation sets. The equation means that anything that resides in A and C circle is part of the set. So that means that the AU set is everything that involves in there. So since we have 3 Venn diagram circles, let's break that down. We know that all of A and C are filled up. But there are parts of B that's going to be filled up as well. And that's going to be because A and B have a spot, A and C have a spot, A, B, and C have a spot. And those are going to be included because it's all of A and all of C. It doesn't matter what part of it it is in right now. And so that's going to be what this one is going to be about. And so set upside down UC. So this is a new one. So this set means that anything with a circle and C circle that is the same. That means we're not paying attention to what all A and all C have this time. We're looking at what just A and C have together. We're bringing whatever's together with A and C. That's what we're going to be looking at, that amount, that number, or whatever it is we're going to be watching for. And since we're going to go back to, it doesn't matter what that B is in here because it's part of A and C. So that's going to be included. Next, we're going to solve a problem in real life. So say a public school wants to understand how many football players, hockey, and cricket players are playing all on the same team. And so we know that there are 65 students playing football. And so we're going to write that as a whole. So all the football players are going to be 65. 45 play hockey, 42 play cricket. 20 players play football and hockey. 25 play football and cricket. 15 play hockey and cricket. And 8 play all 3 games. So since we know that 8 is going to be in the middle because all football, hockey, and cricket are played by 8 players, we're going to put that in. And that's going to be in the white. So we know there are only 20 football players that play football and hockey. So, and that we know that 8 play all together. So we're going to take 20 minus 8, and that gives us 12 in the yellow. And so we're going to put that for football and hockey, excluding the cricket, because we're just looking at the football and hockey portion of it. So we're going to write 12 in. Then we know that there are 25 players that play football and cricket. So we're going to look at that. So we know 25 minus 8 gives us the number 17, and that's going to be in the green portion. And so we're going to write that in for football and cricket. And then we're going to look at the overall football. So football, we're going to write in the equation of 65 at the beginning because there are 65 students playing football. And then we're going to put in parentheses, we know that there's 12 students who play football and hockey. We know there's 8 students who play all 3 sports. And we know that there's 17 students who play football and cricket. And then we're going to close those. So we're going to add those together. And that is going to give us 12 plus 8, which is 20. And then 17, which is 37. So 65 minus 37 equals 28. And so that gives us the number 28 students of who only play football alone, no other sport. Next, we're going to look at the pink-purple highlighted area, or the orange area, my bad. So we know that there are 8 students who play all 3 games. And we know that there's only 15 students who play hockey and cricket. So we're going to make 15 minus 8. And that is going to equal 7. So we know that 7 students play cricket and hockey. And now we're going to look at the purple and pink highlighted area. We know that there are 42 students who play cricket all together. And we know that 8 of them play all 3 sports. We know that 17 of them play football and cricket. And we know that 7 of them only play cricket and hockey. So we're going to do like we did before for solving for football. We're going to start with 42 minus, and then we're going to put in parentheses the 8 for all 3 sports, 17 for football and cricket, and 7 for cricket and hockey. We're going to minus that, and that's going to give us 10. So 10 students alone just play cricket. And then we're going to look at hockey now. Since all of those spots are filled up, hockey students have 45 students all together. So we're going to write 45 in the beginning. We know that 12 of those students play football and hockey. We know that 8 of them play all 3 sports, and we know that 7 of them play hockey and cricket. So when we add those up and minus it, we get 18 students who play hockey alone. And that is how we're going to solve that Venn diagram. The end. I hope you enjoyed the Venn diagrams and how to learn about the equations and what areas to really pay attention to when you're looking at those equations, and have a wonderful day. Thank you.